Hello everybody, today we are gonna look at a pressure switch. This is an old one I want to use for a project, so I had to disassemble it and clean it, and I decided to show you how it roughly works and how it looks inside. First of all, this is a pressure switch in an assembled form. They're a bit different. This one is mostly for water, so it doesn't have this automatic on-off switch, and the ones used for compressed air have most of the time a little vent here, and there's more like a star connection for overpressure release for your gauges and everything. So this one is more of a water switch. They work. What is this pressure switch? It's more or less a device which turns on and off your water pump, your compressor, and so on. So let's open this one and I can show you how it roughly works before I show you this in a complete fashion. So yeah, you have your ingoing and outgoing power cords. One goes to the motor and one goes to your outlet. And you have multiple springs. Sometimes you have 3 and more, depending on what features this thing has. But you have, most of the times is written on it like pressure and delta pressure, for example. The first spring, you select the minimum pressure on which it will kick on and start pumping, and the small spring you can rotate and make it harder and softer, and you can select when it should off. And yeah, after this spring gets tensioned, this spring will be your on-off more or less, and it moves this big metal plate underneath, which moves this lever on the side, as you may see, this one, and goes inside this block where you have contacts like this. So yeah, this is more or less just a huge on-off switch, and it switches depending on what pressure goes in, and it doesn't really matter if it's compressed air or compressed water, because your water in your water tap has pressure too, or it wouldn't run out. It would just rip. So everything has pressure more or less. Your garden pumps have pressure, so this is what you sometimes have on a garden pump for turning on and off. So yeah, let's look at everything step by step. First of all, we have our base plate. It has some rubber grommets and plastic to secure the wires going in and out. So let's put everything together. As I said, this is for a project, so I'm not gonna assemble wires and everything to it, at least not for now. There should be a video coming at some point when I'm doing my project for this. I'm not really finished with designing and planning, so I don't have an exact plan how I'm gonna do it, but I do know that I need one of these. And yeah, this is another plate which goes in this. This holds the springs and levers and everything. This is more or less a base plate which goes on top of this base plate. And it just stacks everything. And now comes the interesting parts, because now is actually the switch itself. You have your, let's see what was first. You have your big plate, which has the pressure and delta pressure holes. I have to get it in this groove back here. So let's see, how can I get it in here? Removing it was way easier. I think I got it. Yeah, now it's in. And I think this metal bracket is a bit bent too. At least this corner looks a bit bent. So let's try bending it maybe a bit back. Because this corner was bent too, so yeah. It could be bent. And it looks a bit bent. Yeah, now it looks way better. Yeah. A bit more, and now it looks way better. And now let's try reassembling it. And it might be a bit harder now, because now it's a bit of a tighter fit. Yeah, disassembling was way easier, but way more messy because everything was in grease and dirt, and yeah, it was a bit messy. And now it won't get into this corner. That's a bit annoying. Why won't it go in this corner? It's a corner which was bent. Now it is in. So yeah, now it's in. This is a mechanism. Let's zoom in a bit. This is a mechanism which engages and disengages the lever. This is the lever itself. So let's put it back in. Let's see, it was this way. This lever has some grooves on the side, as you can see in the base plate. These are the contacts. The contacts are actually interesting because it's a double brake mechanism. It's not like your typical cheap relays. Let's see if I don't think. Yeah. I don't remember if this one, but yeah, this one's, for example. I can show you how it looks. This is more or less a pair of contacts, this two, and this is another contact. A typical relay, let's see here, this side you can see it a bit better. It has a normally open and normally closed, so yeah, there are two contacts more or less. But this metal piece makes only connection to one side or another. It doesn't disconnect on two sides at once. This type of switches, like these big ones. This ones we call relay, and this one I don't know how it's called in English. In German we say Schütz to it. It's more or less a bigger relay, and it is more or less the same design as this one's. It has two connections on the sides, and you see here are like a wobbly bar with 2 points and like 2 switches, because you have 2 pairs, so you have 2 metal thingies, and it contacts more or less both things and disconnects both things. And this is how these big ones work more or less. They are a bit beefier. So yeah, this thing is a bit beefier too. It's not like this small dinky relays. It's like these big boys. And you have the contacts here. You have your ingoing and outgoing. As I said, it breaks both contacts at once. It doesn't break just one side like a switch. It breaks both sides. So yeah, there's a plastic thing covering this grounding connection. It's actually labeled ground, if you can see it here. So this whole metal thing is grounded. This lever slides in from behind. Like this, and I've pushed it in upside down. Now let's see. Now it should fit perfectly nice. And this is the switch, moves up and down. And The next thing is this small spring. I think I should show how it all works. There's a little groove. Let's zoom a bit more. There's a little groove where you put the spring like this, and the other side goes into a hole in this lever, as you can see, so it moves with this lever. Depending on this position will change. So this goes all together. Like this. The spring is inside and now it springs up, and depending on how much pressure is pushing this plate up, let's see, can I use a screwdriver? It's not this, it's this one. Depending on the pressure up on this plate, it has more play, and yeah, this plate gets pushed down by this springs. So yeah, let's just assemble more and more. I think you can see it a bit better. The small spring, it's interesting. The big spring uses the base plate as a contact point, and the small spring has a step on it. As you can see here, there's a step. So the big spring, the small spring's delta pressure spring doesn't contact plate until it gets up a bit. So let's assemble a bit further. Maybe move the camera a bit down. For this I have to loosen everything a bit, because I didn't plan that everything is so tiny. So yeah, this small spring, it has a little washer plate. A spring gets sandwiched in between of two, and a nut with Loctite on it, so it doesn't unscrew from vibrations and so on. But the Loctite is actually pretty soft, which is actually pretty funny, because we have some Loctite nuts which are not moving that easy, and this one I can move with my hands. So yeah. Now the big spring, it has a beefier spring, a beefier washer, and a beefier, no, the same nut. It's exactly the same rod size, just longer. And here it's actually pretty hard to get grip of it, because it's in a groove inside. So we have to use. Now it's getting tension. Yeah, should be enough for the beginning. I have to adjust these springs later in my project, so I'm not gonna trying to adjust for some random tension. So the next step would be the contacts. There's a plastic cover and this comb looking thing, and that's where you put in your contacts. Now I have to look a bit how it was. It was like this. I did assemble it a bit of a time ago, so I have to think how it all goes together first. Yeah, it slides in. Oh, it can actually disconnect 3 wires. If you modify it a bit, like here's a slot where I could put a third one in of these, and this has holes. Do these have this option? No, they don't. So they're then for only two wires. And these can, in theory, if you most likely buy, I think it's a 3-phase. That's why it has 3 holes. So you could disconnect a 3-phase motor, for example. But this one is designed for just a 230 volt 1-phase motor, so you have the neutral and positive. This is why only 2 are populated. And yeah, you slide it in. This is where you connect your wires. It's just like pressing in. This one is actually pretty loose inside compared to this one. Maybe switch places. Yeah, now it's a bit tighter. Yeah, now it's a bit better. And the bottom 2 contacts, similar approach. There's a little step in the end, so it can't fall out, so it has to slide down. And it's a bit wider, as you can see, so it doesn't fall through the plastic, it just goes in for a specific way. And now you have your 2 bottom contacts, and they do contact with these 2. Yeah, the focusing is not that great. So yeah, these 2, it's in contact with these 2. And all these slide from the side. There's a groove in the metal, a slot, and these have some T connections. I think it would be better if I've moved it a bit up, and I just, yeah, doesn't really matter. I can put these contacts later in because I'm starting to lose them. It gets held down by this clip, but for now I just want to put this one in. And something is preventing me. Yeah. Maybe rotating 180 degrees would be a good option, because now it fits perfectly. Now it's in. And I think I'm gonna secure it with these 2 bolts to prevent it from falling out. They screw in it with metal plates, so it gets pushed down onto this plastic. And now let's put this connectors back in. As you may see, now the contacts are closed. Here they are closed, and on this side you can maybe see them closed, yeah. And depending on how much pressure is pushing down onto this metal plate and this lever, it will disengage and look like this. And if the pressure is low enough, it will close back. The pressure gets higher and higher and higher, and it will press down and disconnect it. So let's see, can I demonstrate maybe? Yeah, everything falls out because I don't have the cover on it. What I want to see if I can demonstrate the pressure from underneath. Yeah, it's a bit hard to press. Maybe I'm gonna use the original plate. But if I'm pressing on this metal plate, where normally the air would go, you can see the one plate going up and the other one. When this plate goes up, this plate goes down, this lever goes down. And it's designed so it disconnects hard, so it doesn't disconnect slowly and it makes an arc, but this is designed to make a fast disconnection, so there's not a big arc building up between the contacts, because arcs do degrade the contacts. So if I'm pressing slowly, at some point it will just click. It doesn't slowly move down, it makes a rough disconnect and connect. So let's finish reassembling. Like I said, this is multiple options, like it looks like, because you have two more places where you can put contacts. So it's a 3-phase disconnection switch if you modify it. But for me it's just a live neutral plus ground underneath. So now the bottom piece. To make everything tight, because now it's just a huge hole where air can go out, you can just put pressure underneath here and yeah, it will all escape. So they designed a way to make everything tight. This is where the water, air or whatever you're using is connected. It gets in a membrane, a rubber piece. So the water can't go out, but the pressure will more or less press against it. And the other side of this membrane, there will be this plate. And this is on the outside air. So this is tight, and the water just pushes against this rubber. And this rubber pushes against this metal piece like a sandwich. And these two metal hooks go through this plastic, through this metal frame, and push with these spikes. It's spiked because if the metal plate, let's see, what do I have here, like this. If I have a metal plate and pushes like this, it can move up and down and it will still be on the same spot pushing. But if you're using something flat, for example this box is maybe a bit too big. Let's see, maybe. Yeah, let's find something that is flat but not too big. Yeah, like the screwdriver. If you're pushing down with something flat, you have one corner pushing, and then it goes down, it pushes with another corner, so it puts a bit accuracy and wobble into everything. This is the reason why they're making them this spike shape. And it goes through everything, and there's actually a bit of a groove, as you can see here, where it sits in, so it can't move left and right. Everything is more stable this way. Yeah, as you can see, if I'm putting some pressure on it, it gets pushed down onto these steps. You may see it down in here, like small holes. They're on this side, you may see it here on this metal plate, a dot, and here's a metal dot, and it's exactly the position where this sits. You may see it wiggling down there, and this pushes against everything. And then there's this rubber sealing and this metal piece. And it has some plastic standoffs so it doesn't move around. Oh, it gets placed in a perfect position, everything. And gets sandwiched by screws again. This metal plate, this rubber, this plastic and this metal is squeezed together with screws, so it's tight. And this is more or less the way how this all functions. The last thing left is just the cover. Let's tighten it over cross so it gets tightened. The same. This is a bit stripped or something. Oh, not the same size. Because in these 3 screws and screwdrivers it's perfectly, but this top one is a bit. I'm still thinking, why the hell is everyone still using a Phillips head or these type? Why not Torx or Hex or something? It's way more comfortable than these. But yeah, this is a common one, so everyone uses them. For me, these type, this square ones, and these Torx ones are way better. But yeah, everyone uses this Phillips type. And this is just the cover. It has a hole back here and just screws on like a plastic screw. And yeah, it's a bit ripped, so it doesn't want to go down. Oh, it wasn't to go down because this one is a bit too high. It has to go down a bit more. And the camera will stop recording any second. So yeah, this is how everything goes together. Yeah, now it's tight. Thanks for watching and see you next time.